I'm presenting progress from the first part of the Improving DBI project funded by the R Consortium. So the second part of the project is about to begin, so this is a good opportunity to wrap up and show what's been done and what's next. So Jim has talked about DBI. For those who weren't here, quickly, it's an S4, a collection of S4 classes and interface that would link your R code to particular database management systems, DBMS, or in Jim's case, to a whole collection of database management systems. So it's been around since forever. We'll see another DBI backend in a few minutes by Ian. Problem so far with DBI was that the specification of the interface was a bit loose. So we had the methods, we had the description of the parameters, what you were expected to input it for these function arguments, but an interface is more. An interface is a specification also of the behavior. What do you expect from the methods for what kinds of input? So if we look into specifying the behavior explicitly, we make it easier for both implementers and for the users. So the implementers get a test suite for free because the specs are also code that runs against your DBI backend. Clear expectations, what needs to be done. You don't need to think about what do I have to do in what corner case, because the specs try to be very clear about this. And we get a boilerplate. So for those who started a new DBI backend, there is an R package that you can start with that contains mockups for all the methods, which you can then fill. Users get reliable behavior from the interfaces. Ideally, we would like them to be able to exchange one backend with another, one database with another. This is difficult if you start looking into the various SQL dialects, but well, it's a good start anyway. And we've worked on the documentation. So this shows the packages involved in this project. The green packages are almost done. The yellow is ongoing work, red, next steps. So what we see here is also dotted lines. These are not actual dependencies, but suggests. All these packages would use DBI test to run their tests. So I'm going to walk through the packages, show quickly which of them do, what's been done for them, and wrap up afterwards. So for DBI, the API was relatively stable. I removed one method that's been added recently that was about checking compatibility of the interface, which is now done in this new DBI test package. Now, I'd like to talk about three major changes. We've added quoting of identifiers and strings. So now, before the DBI has two methods for reading and writing tables, and before it was unclear what to pass as a table name, and especially in the case of more complex table names like schemas or table names that could contain special characters or reserved words. So this wasn't clear. DBI now has the notion of quoting. So what you can do, you can pass a character which will just give you this object with this name, can contain spaces, reserved words, special characters, no matter what. We won't try to fix the name for you anymore. Or you give it a quoted identifier, an object of class SQL, for example, which will be passed verbatim to the database engine. So that's one thing. Now we now distinguish between queries and statements because this seems to make a difference for some database libraries. The effect is that now for RSQLite you're going to get warnings when you're using db get query when you're supposed to use db execute. I'm sorry for that, but this is just to be consistent here. Jim has talked about parameterized queries. That's another big new thing that's available now consistently in DBI for all backends that wish to support it. Now, I'll quickly show you the documentation of one of the methods, DBSendQuery. That's the way it's rendered from our continuous integration system. That's how the specs look like. Now, it's the same text essentially, but this is deliberate. So we have both documentation and specification of the methods drawn from the same source, slightly reformatted, but essentially it's the same text. It's makes it easy for the user. If you want to look up the specs for a specific method, you just have it in the help. But also you have this complete document, this specification for all the methods that DBI offers. And actually, if you scroll down, this section's value and specification are the specs. Each word, each sentence there corresponds to actually a piece of code that would run against your DBI backend and test if this is true. So this is what it looks like in the source code, with support from our Oxygen 2 that allows me to write this specification, the textual specification, very close to the actual tests, which means that whenever we need to enhance or adapt, we can at least, it's easier to remember that you need to adapt the text as well, along with the text. So, if you want to use DBI tests in your backend, then easy thing to do is to run it with test.dat. You establish a context. This is how you tell DBI test how it is supposed to access or how it's supposed to instantiate a connection to your backend. And there is a section tweaks. So we just cannot write the tests in a way that they work for all the backends. For instance, our SQLite just doesn't have date and time data types. It doesn't. So we give it a tweak which tells, okay, we don't have typed timestamps, and the test adapt to this. So, and this test all call, when run as part of your test suite, will execute everything adapted with the tweaks and tell you whenever something's wrong. Now, coverage results, I was a bit disappointed and surprised. So if you run only with DBI test, we're worse than when running the additional tests in our SQLite. That's testing specific or added functionality that is not part of DBI itself. But, well, I think this is because the custom tests would also execute most what the DBI tests cover, just not as thoroughly as they can. And you still get added value from if you run both tests. So that's okay. And I mean, for free, getting like 70% coverage is still okay, I think. Now, I think, Jim, you're using ODBC. I have received feedback from Hannes and from Emmanuel Costigan, would be happy to talk afterwards, who are already users of this package. I've talked about our SQLite. It's a file-based database, a very unique beast. You can stuff in different data types in all the columns. So no matter what you declare the column, you still can put in everything. Well, it's okay, but the DBI backend has to handle that. We have had, it has about under 30 downstream dependencies on CRAN and bioconductor, which makes it a very good source of tests, actually. A very good inspiration of how people would use your code. Very unexpected. So there's a row names argument, for instance, in a few of the functions. Some packages pass 1. I don't expect a 1 there. So we had a 2-stage release process. One stage was to try to move towards the specification without breaking compatibility too much. The version 2.0 was just, well, no, with the specs, please update. So there was a bit of friction with that. and for the two new backends, I'd like to do it differently. Now, to remaining points, those are very small packages, essentially S3 classes for data types, which are supported by database, but are not as common in R. Edge messages for time of day data. There is a diff time data type, which disrupts. It's formatted a bit nicer, but no magic. Actually, just a container to get the data out from the database and format it nicely before you come up with ways to use it properly. Blob is for binary data. Bit64 has been there before. This is one way to implement a backend that returns 64-bit integers. So actually, DBI tests will not test that you are using bit64. No, we just say if this is a 64-bit integer, when you convert to character, it has to return the full representation. When you convert to numeric, it has to return the closest numeric equivalent. That's what it tests. Bit64 fulfills it. If we later decide to change implementation, shouldn't be affected by the tests. So that's the cute boilerplate package I mentioned before. Now, for the second part of the project, we'll be working on 2 new backends, 2 re-implementations from scratch. I know there is our MySQL and there is our PostgreSQL, but I just want to take the risk to make these fully DBI compliant, because this is very likely to break existing not only packages but user code, to which I have no access. I have no idea how users are using this package, and the feedback would be very slow. So new implementations, new package names, gives you the chance to choose when to transition from our MySQL to our MariaDB. If at all, maybe you want to move to ODBC, your choice. So, and then one big issue to resolve is schema support. We have a pretty good idea how to do this, but maybe you have other ideas. So that's one of the few remaining things where we'd also need to update our SQLite when it's done. So it's all on GitHub. Thanks for your attention. I'm ready to take questions. Thank you.
Questions? All right.
This is a really basic question, but would you be able to just describe real quick the difference between the DBI and the ODBC packages?
Okay, so ODBC is an implementation for the DBI interface, as it currently stands. So ODBC behaves like our SQLite. When it comes to the implementation, it just offers access to a various number of other databases, which ODBC supports. So the main difference is perhaps that this is just one more layer where things could go slower or things could go wrong. So apparently this doesn't seem to be an issue for our SQL Server or even otherwise. But I'm actually happy to provide alternative implementations that link directly to the native database driver. So to just have something to compare it against.
Any more questions? So I think while people think of questions, you can talk a little bit more about what future work you're planning on doing for DBI, if any. And if anyone has questions, please raise your arms while Kirill speaks, and I'll get the mic to you.
Well, I've mentioned our MariaDB. I've just started the repository, migrated the issues, the open issues over, and well, the task would be just to enable step by step the tests that are failing currently and implementing these. So one big issue is that a certain kind of queries, there's like use database queries or set database parameter to something queries would not work with the current implementation just because the database library doesn't support these kind of queries with parameterized queries, which are now the default. So there's a little bit of technical work to be done, but I expect to be to have these by end of the year. So that's the general idea.
Is there an equivalent DBI that could apply to non-relational databases like MongoDB?
Can you?
So is there a package that could cover many? Is there a package that could cover many non-relational databases, such as MongoDB or Neo4j?
So this has come up, but then what would be the query language to access these kinds of databases?
I'm
Is
not
it
sure.
still SQL?
Sorry?
Would this be still SQL, or
No.
would it be something else?
It wouldn't be SQL.
So, well, DBI is focused on database that supports SQL. That's the basic assumption.
Oh, I know
So
it can't work for DBI. I'm curious if there's any ideas for packages that would be similar to DBI that would handle many cases like that, which right now are sort of divided.
I'm not aware of any, but I think this would be worthwhile to do in a context where you want to write one DB plier backend against all these beasts. So it would be worthwhile thinking about this, certainly.
We have time for one more question, if there's any takers. All right.
It's more a comment. I just want to thank you for the work that you're spending on making these things behave similarly, because it's something that nobody would tackle, and you went for it, so thank you.
Thanks a lot.